I am Larry Hatcher. This is Psych 302, Computer Applications in Data Analysis. And for this video, it's going to be Jamovi Exercise 125.01, ANOVA with two within factors, input through interpretation. Specifically, it's going to be part one of this exercise. We have a note at the beginning of the exercise that says it's divided into two parts. This week, you'll complete part one, which involves downloading the data set and performing the statistical analysis. In other words, this week, you'll complete task one. Then next week, you'll complete part two, which involves completing a multiple choice quiz, which is task two, and uploading your Jamovi document, which is task three. Let's scroll down a bit and see the fictitious investigation that produced data for this exercise. Investigation: background light, background sound, and minutes of sleep. Imagine you're investigating treatments for insomnia, the disorder in which people are unable to get enough sleep at night. Current study includes a sample of 14 adults diagnosed with insomnia. Its purpose is to investigate the effectiveness of two different interventions for treating insomnia. The dependent variable in your study is going to be minutes of sleep, or just minutes. Obviously, if someone is suffering from insomnia, we're looking for something that will increase the average minutes of sleep they get in a typical night. Factor A in the study is background light or just light. It was manipulated by either turning on or turning off a small nightlight which had been placed in the participant's bedroom. This factor consisted of two treatment conditions. During some weeks, participant experienced the dark condition, in which a small nightlight was turned off and the participant's bedroom was kept pitch black all night long. During other weeks, the same participant instead experienced the dim condition, in which the nightlight was turned on with just enough illumination to be able to see objects in the room all night long. Study also included, and I am on page 2 now, study also included factor B. A device called a sound generator, that is a sound screen, was placed in the individual's bedroom so that different sounds such as fan or babbling brook could be produced all night long. This allowed researchers to manipulate factor B, which was named background sound or just sound. It consisted of three treatment conditions. During some weeks, subject listened to the sound generator creating the sound of a window fan whirring all night long. We will call this the fan condition. During other weeks, the same participant instead listened to the sound generator creating the sound of a babbling brook all night long. We'll call this the brook condition. And finally, during other weeks, the same subject attempted to sleep with the sound generator turned off and not producing any sounds at all. We will call this the none condition. Factorial design. Figure 1 illustrates factorial design used with this investigation. In the figure, the two horizontal rows represent the two conditions of factor A, background light. Three vertical columns represent the three conditions of factor B, background sound. Now remember, we had just one group of 14 participants, and each participant was exposed to all conditions under both of the factors. Factor A was light, and this row represents the dark condition. This row represents the dim condition. Factor B was sound. This column represents none condition. This column represents fan condition. This represents the brook condition. Inside a given cell, I have all 14 participants to remind us that each of the 14 participants was exposed to all conditions under both of these independent variables. Let's see if I put that into writing next. Both independent variables were within subject factors, and this meant that a given participant provided 6 separate scores on the minutes of sleep dependent variable, a separate score for each of the following combinations of conditions. We can refer to these combinations of conditions subconditions. Each participant provided a score on the minutes of sleep dependent variable under the subcondition in which they spent the night in a totally dark room with no background sound at all created by the sound generator. Each participant provided a minutes of sleep score in the subcondition in which they spent the night in a totally dark room with the sound of a fan. Each provided a score on the subcondition when they're in a totally dark room listening to a babbling brook. Each provided a score on minutes of sleep in the subcondition in which they were in a dimly lit room with no background sound, a separate score in the subcondition where they're in a dimly lit room with a whirring fan, and a separate score on the dependent variable when they're in the subcondition with a dimly lit room and the sound of a babbling brook. Given participant was exposed to one of the 6 combinations of treatment conditions for 2 weeks, and at the end of that 2-week period, the researchers determined the average minutes of sleep that were displayed by the participant during that time. This meant that each participant provided 6 separate scores on the dependent variable. Average minutes of sleep the participant achieved when trying to sleep in a dark room with no background sound, average minutes of sleep achieved in a dark room with a whirring fan, and so forth. 6 combinations of treatment conditions. The fact that there were 6 combinations of treatment conditions and a given participant was exposed to each of these combinations for 2 weeks meant that the entire study lasted a total of 12 weeks. I am still on page 3, about halfway down page 3. We have research hypothesis. Based on a review of the research literature, you predicted that there would be a statistically significant interaction between background light and background sound in their effect on minutes of sleep. Specifically, you predicted the following. Research hypothesis, there'll be an interaction between background light and background sound, such that there'll be a relatively strong relationship between background sound and minutes of sleep when participants are in a dark room, but there'll be no relationship between background sound and minutes of sleep when they're in a dimly lit room. Following figure illustrates the nature of the interaction that you hypothesized. And on page 4, at the top of page 4, here is the hypothesized result that you predict before you actually conducted the investigation. One of our independent variables was sound, the sound made by the sound generator. It had 3 conditions, none versus fan versus brook. One of our independent variables was light. It involved either a dark condition or a dim condition. Notice that background sound does have an effect and allow people to get more sleep, but only if they're in a totally dark room. When we look at the solid line that represents totally dark room, we can see people listening to a babbling brook got more sleep than those who listened to a fan, and those who listened to a fan got more sleep than those who heard no sound generator at all. So it looks like background sound does have an effect on minutes of sleep, but wait a minute, that's only for those people that are in a completely dark room. If you instead look at the dashed line, which represents the scores that they displayed when they're in a dim room, background sound doesn't seem to have any effect. There is no difference between minutes of sleep they got when listened to babbling brook versus sound of a fan versus none. This is a classic interaction. Remember, an interaction usually will involve non-parallel lines. This line is not parallel to this line. An interaction term is all about it depends. If somebody asks, is it true that sounds made by a sound generator can help people get more sleep? Your answer would be, well, it depends. Background sound has an effect if people are in a completely dark room. Background sound doesn't have any effect if they're in a dimly lit room. Now remember, this is your prediction. This isn't necessarily the results you're going to see, but this was your hypothesis of the results that you hope to see. So let's continue to the data set to be analyzed. I am still on page 4. Halfway down page 4, we have this data set to be analyzed. Table 1 provides the raw data that you'll analyze for this exercise. And here on page 5, we have table 1. This is the data set. Notice to the right of the heading light, we have the 2 conditions of background light condition, dark versus dim. To the right of the heading sound, we have the 3 conditions of background sound, none versus fan versus brook, and then it repeats itself, none versus fan versus brook. And most important, to the right of the heading variable, you can see that I have assigned a variable name to scores obtained under the various conditions of the two independent variables. Now, the scores that we see in the body of the table are minutes of sleep. And when we look at this column that's headed dark none, here we see the minutes of sleep that each participant displayed when they're in the dark room with no sound generator sound at all. In the variable that's named dark fan, these are the minutes of sleep that they got when they're in a dark room with the sound of a fan. Skip over to dim none. This is the minutes of sleep that they got in a dim room with no sound background. When we look at the variable called dim fan, this is the minutes of sleep that they got when they're in a dimly lit room with the sound of a fan in the background. And I will probably put that into black and white below. Let's go to the bottom of page 5. At the top of each of the 6 columns is the variable name that had been assigned to that column. Specifically, the column headed dark none, providing scores on the dependent variable minutes of sleep per night for each participant when they spent the night in a totally dark room with no background sound. The column headed dark fan contains scores for the same participants when they spent the night in a dark room with the sound of a fan. The column headed dark brook contains scores for the same participant when they spend the night in a dark room with the sound of a babbling brook, and so forth. Description of each of the 6 variables. And here we just put in black and white the words that I had spoken. So on page 5, we have the data set that will be analyzed. Now, lucky for you, you will download this data set, as we'll see in a minute. I'm on page 6, and halfway down page 6 is where we get our first marching orders. Exercise part 1. Begin work on task 1, performing the analysis in Jamovi. You do not need to upload anything or complete any multiple choice quiz today. You'll do that next week when you complete task 2 and task 3. Word of warning to my students. You may be tempted to think, well, wait a minute, if I'm not uploading anything today and if I'm not completing any quiz today, I'm just going to wait and do everything next week. Next week, I'll do task 1 and task 2 and task 3. You may be tempted to do that, but I discourage it. I encourage you to go ahead and do the instructions described for part 1. Do complete task 1, because you're going to find that it is an analysis that involves many steps and many decisions to be made. You'll do yourself a favor to do it this week and have this part of the exercise done. So with that in mind, I am still on page 6, halfway down page 6. This is what you'll do for part 1, the section of the exercise assigned for this week. Task 1, performing the analysis in Jamovi. You'll now use Jamovi to perform ANOVA on the data in the preceding table. In doing this, follow the instructions that were provided in Lecture Notes, Chapter 125, ANOVA with 2 within subject factors. The data set that you'll open and analyze is named Light Sound Minutes ANOVA 2 within data, and you can download it from Canvas modules. So you do not have to type up this data set, assuming that you are a student in my course. You don't have to type it up. You'll merely download the data set in Canvas modules. I'm back at page 6 now, toward the bottom of page 6. Once you've opened the data set in Jamovi, you'll request statistics and plots similar to those that appeared in the lecture notes section headed Requesting Descriptive Statistics and Performing the ANOVA, except that you obviously will analyze different variables. Yes, you'll request all plots and statistics that had been requested in Lecture Notes Chapter 125. This means that you use both the Jamovi Descriptives procedure as well as the Jamovi Repeated Measures ANOVA procedure. Word of warning, this is the part of the analysis that is going to be time-consuming. You have to look carefully at my instructions in the lecture notes and see how I perform my analysis and come up with your ideas on how you'll perform the same kinds of analyses on your data set. Your data set, of course, has different variables with different variable names and different levels with different level names. So this is going to be where you spend most of your time. Here's one particularly important task. In the Assumption Checks panel, do check the box headed Sphericity Tests, and in the section headed Sphericity Corrections, check the box headed None. I did one thing for you. I made a decision that you're going to perform the ANOVA without any corrections, without using the greenhouse geyser correction, etc. One of your questions on the multiple choice quiz asks about this and asks why that was the correct decision given your results. So you do have to request these sphericity tests so that you can talk about that when taking the multiple choice quiz next week. Important, do add your name at the top of the results panel so that I know it's coming from you. And maybe most important, save your Jamovi file. Even though you're not uploading it this week, you will need it next week because you're going to upload it next week and you need to look at it next week when you're taking the multiple choice quiz that I have available. Now, to make it more likely, you're going to get a good score on your exercise when you upload it and your multiple choice quiz when you take it. Here in the middle of page 7, I have a section that begins preview of some of the correct Jamovi results. If you perform the statistical analysis correctly, results you obtained should match the results provided below. Remember, your Jamovi document should contain more tables and plots than are displayed below. I'll just give you a sample of the output so you have something to check your numbers against. In your results, and I'm on page 8 now, in your results, you'll have a descriptives table. Make sure that your means match my mean. The mean minutes of sleep displayed under the dark none condition should be 307.14. Minutes of sleep under the dark fan condition should be 342.86. So spot check these statistics, make sure they match. Here is what your repeated measures ANOVA table should look like. Check your F statistics against mine. Make sure the numbers you're getting match my numbers. I give you the assumptions table. Mockley's W statistic and its p-values. Do your values match mine? I show you the graph that illustrates mean scores on minutes of sleep for the various subconditions. Make sure that your graph looks similar to my graph. Now, right now I'm on page 9, and we come to a red box. What does it say? End of exercise part 1. Be sure to save the Jamovi file you've just created someplace where you can find it next week. You'll complete task 2 and task 3 below at our next task meeting, or at our next meeting. You do not need to upload anything or complete any multiple choice quiz today. You'll do that at the end of our next meeting. I do strongly encourage you to do the analysis this week. It's going to be time consuming. If you run into problems, you want to have plenty of time to check with me so that I can help you solve your problems. So this is an overview of what you'll do with respect to part 1 of the current exercise. Current exercise being Jamovi exercise 125.01, ANOVA with 2 within factors, input through interpretation.